In this video, we're going to discuss the topics related to operator overloading in C++. So this is our presentation. And as we go through the set of the topics related to operator overloading, I'm going to demonstrate some of these operators and revisit already overloaded operators that we've used in the implementation of our Java-like string. So overall, C++ operators, of course, is a very simple mechanism for improving program readability. And at the same time, if we decide to provide unusual operators for the classes, our own user-defined types, which basically are unintuitive and misleading, that could make programs really unreadable and difficult to maintain and understand. So overall, you could see that for the most part, when we were testing our concept, this Java-like string, we almost exclusively relied on member functions, providing the behavior of our Java-like string in C++. But at the same time, of course, you can call it syntactic sugar, or you can replace function calls sometimes very effectively by providing reasonable and intuitive operators. For instance, here, if consider to have a graphical application with points, and these points will have coordinates, then of course it's probably a good idea to provide an operator such as equals to be able to compare effectively and make it quite readable and intuitive for the user to use. So the kinds of operators that are available: numerical, of course, we have pluses and minuses, multiplication, division, increment and decrement, modulo operator, comparison operators, greater than, equality, not non-equality. There are also structural operators such as subscript operator, also dereference operator, the unary dereference operator, and address of operator. So one operator that we definitely discovered that we have a need for in our application of string class was definitely the one that we just finished discussing a little bit in our previous video, was the assignment operator. And we've discovered that there are two versions of assignment that can be used in your class. So the assignment operator by default is provided at no cost, and what it does is just does bit by bit copy of one object to another object, but sometimes it's not what you need, and the reason for that is that if your class is designed to manage dynamically allocated memory or some other example of dynamically allocated resources, so basically this is the instance of your class, the object of your class in memory, and it could be managing some dynamically allocated memory, and that's exactly what our string class does. And you can have even objects that allocate multiple blocks of memory dynamically, so they're really kind of designed to manage memory dynamically. So in that case, it's possible if you use the default version of the assignment, an exact copy of this object will be created. The compiler will create code for assignment. If you don't provide assignment operator, it will just basically do an exact copy. Every bit that comes from this object will be replicated in this object. So everything contained right here will be also replicated over here by default. So this pointer that holds address of dynamically allocated memory, of course, will be replicated here as well. And so this is what's called a shallow copy, and that's what probably we need to be able to avoid in cases where this default behavior bit by bit copy, which we would refer to as a shallow copy assignment, is not appropriate. So this is a very popular operator that sometimes we need to override to provide our own version of it. So the arguments of operators, of course, we have two basic kinds of operators, like you can say plus, let's say a plus b, okay, or we can say minus c, okay. So here, this operator plus clearly intends to add two numeric types, type of objects of numeric types, and of course this is called a binary operator because it takes the left hand side and the right hand side and needs two operators. So these operators are referred to as binary operators. There are also unary operators, which require only one operand. And in that case, I mean, good examples of this would be also like increment operator plus plus c, or d minus minus. This is of course a prefix increment. This is postfix decrement examples. So, but all of them require just one operand, and they're referred to as unary operators. So the operators actually can be either members of the class or standalone non-member functions. So in that case, if this is a member function, then you can see here an unary operator will require no operands because it is basically acting on the object for which this operator was invoked. And if this is a binary operator, you only need one operand. For non-member implementations, for unary operators you need an object, and for binary operators you need two objects. So I believe we already have these examples in our string. And of course these operators, assignment and the plus equals this arithmetic type of assignment, which we use for concatenating two strings, they require an object as an L value, left hand side value, and so they must be implemented as member functions, but they require only, but all of these operators are binary operators, right? Because when we say A equals B, and this is of course assignment, right? So this, if this was the statement, then these are the two sides. So A will be the this object, right? Object identified by the this pointer, and B would be this another object that we use as the source of the assignment, and this of course will be a binary operator, but implemented as member function, like these two operators are implemented as member functions of our class string. They require only one operand to take as a parameter. On the other hand, we also have an example of this output operator that we use to communicate the content of our string to a standard library output stream object, so that we can basically plug in, just like we do in our test cases. We just simply plug in our strings into this output stream, sending to character output, which is one of the examples of C++ standard library output streams. In this case, if it is implemented outside of the body of the class. So this is just a standalone non-member regular function. Then of course you need both sides. In this case, the output stream on one side and the string object on the other side. So here in our test example, this would be the left-hand side, and this will be the right-hand side, and this is our operator. And you can see that operators or overloaded operators are simply functions with these types of names. And whenever we place this in context, so let me just resize it to do this side by side. When we place this stuff in context, like this, so this is a string that we created already, and this is the output stream as we have in our example right here. So this operator function is invoked, and this becomes the left-hand side, and this becomes the right-hand side, and this is of course the operator function that compiler will decide to plug in to implement the functionality of this statement or this sub-expression where we use one object and another object, and we provide the overloaded operator for this type of code.